Hello, boys and girls, and ladies and gentlemen. We are going to continue our lesson on rational numbers. This time we're discussing integers, adding those integers or signed numbers. So let's get started with the rules for adding integers or rational numbers. So the rules for adding integers. Same signs, add the numbers, and keep the same sign. For example, positive 5 plus positive 8 equals positive 13. Notice both signs are plus or positive. 8 plus 5 is 13, and we keep the same sign just by adding the numbers, so that's why it's positive 13. Likewise, negative 2 plus negative 1 equals negative 3. We add the numbers, 2 plus 1, that equals 3, and we keep the same sign. Why did we add the numbers? Because the signs were the same. So again, same signs, add the numbers, and keep the same sign. Rule number 2. When the signs are different signs, subtract the numbers and choose the sign of the larger digit number. For example, positive 11 plus negative 8 equals positive 3. Now why is that? Well, first of all, the signs are different. So since they are different, we cannot add those numbers, so we have to subtract them. Positive 11 minus 8 would give us 3. So 11 minus 8 is 3. Now, which sign do we choose? Well, 11 is a bigger digit than 8. So since 11 is bigger, we'll choose the sign that's next to the 11, which is positive. So that's why we chose positive, because 11 was bigger. So it's positive 3 is the answer to positive 11 plus negative 8. Let's try another example. Negative 30 plus positive 10. Again, the signs are different. So since they are different, we subtract the numbers. 30 minus 10 is 20. And now we have to decide which sign to choose. Well, 30 is a bigger digit than 10. Since 30 is bigger, we will choose the sign next to the 30, which is negative. So our answer is going to be negative 20. So negative 30 plus positive 10 equals negative 20. Remember, different signs subtract the numbers and choose the sign of the larger digit number. Here are some vocabulary words associated with that. Sum, the answer to addition. Plus. Difference, the answer to subtraction. Minus. Product is a word we haven't talked about yet. The answer to multiplication. Time sign. Quotient, the answer to division. We haven't talked about that yet. The division sign, or you can use a fraction, which means division sign. Oops. And power, the answer to exponential problems or exponents. That's when you have some number to the second power or to some type of squared or cube or something. The little 2 in red is the exponent. So power is the answer to exponent. So here's an example. Try it on your own. Add the following. Negative 2 plus positive 7. I'll give you a few seconds. Did you come up with your answer yet? Well, let's take a look at what I did. I first took 2 negative tiles, and then I took 7 positive tiles to represent -2, and I'm going to combine that or add that to +7 tiles. But I remember the rule says if the signs are different, I cannot add them. So these are like positive and negative charges. When they combine together, a positive charge and a negative charge, when they combine, they combust and blow apart and disappear. And this is what we're left with. We're left with these positive charges. There are 5 positive charges. So our answer to this question is going to be +5. And remember the rule. We subtract the numbers. 7 minus 5, 7 minus 2 equals 5. And when we look at the digit 2, we see that it's smaller than the 7. We have to pick the digit sign that's larger, which will be +5. So our answer would be +5. So I hope you got that answer. Let's try another one. Ooh. Add the following. -3½ plus 5 3/5. Dr. Robinson, those aren't integers. You're right. Those are rational numbers, though. Because remember, our topic was rational numbers. We were adding integers, but we can also add some of those mixed with integers with fractions attached to them. So we have -3½ plus 5 3/5. I hope you remember how to deal with fractions. So I'll give you a minute. All right, let's take a look at this. First thing I did was I took -3½, I changed that to 7/2, -7/2. How did I do that? I multiplied 3 times 2, gave me 6, added 1, gave me 7, that gave me -7/2. Then I took 5 3/5, changed that to 28/5. By multiplying again, the whole number 5 times the denominator 5 gave me 25. Add the numerator 3, gave me a new numerator of 28, and I kept my denominator of 5. Now in order to add these two new fractions, -7/2 and 28/5, I have to get a common denominator. Well, to get a common denominator, what would be easy is to multiply both of those by 10. So I'll multiply by each other to get 10. So I multiplied 2 times 5, that gave me 10. So now I'm going to change -7/2 into 35/10, which is negative, by multiplying top and bottom by 5. I'm going to do the same thing over here, change these to 10, 28/5 to 10, by multiplying both of the top and bottom by 2. 2 times 5 is 10. 28 times 2 is 56. Now that I have 10 on the denominators, I can now add the numerators. But look at the numerators. They're both different signs. I cannot add different signs. I have to subtract. So when I subtract these two, I get 21. But which sign do I pick? Well, 56 is a bigger digit than 35, so I'm going to pick the digit sign of the 56, which is positive. And so I get 21 over 10, which is my fractional answer, and I can divide 21 by 10, which gives me 2, remainder 1, or 2 and 1/10. So I hope you got that as your answer. That was a tough one. So check for your understanding of that problem. If you're still uncertain, bring in your questions tomorrow and we'll discuss it. Here's where we'll pick up on tomorrow. So give it a shot. Hopefully you'll get the answer and you'll get it right tomorrow. All right. I hope you got something out of this video. Remember, rewind the video, take a look at it again. If there's something you need to see or write down, please do it. Please try it again. And remember, be prepared tomorrow in class as we review rational numbers, integers, adding, and we're going to sign off right now. See you tomorrow.